Dear students, we are checking the settings. The AAT will be starting at 4 p.m.
Good evening, everyone. I welcome all of you for a talk on significance of electronics for all other departments of engineering. We have with us the speaker for today, Shubham Shashwat Mohanty, who is working as a techno-functional consultant at High Radius Technologies, Hyderabad. Have with us, just a minute. Shubham Shashwat. Yes, I'm sorry for the interruption. Shubham is an alumni of PSI who has completed his Bachelor of Engineering in Electronics and Communication Engineering from Dayanand Sagar Academy of Technology and Management, which is a sister concern branch of Dayanand Sagar College of Engineering. He also has an integrated program in business analytics from IIM Indore. A few of his many achievements are he has received client recognition for 3 consecutive quarters for excellence in delivery. He is the winner of Accenture Excellence Award for the year 2019. And there are many more. As I told, there are only a few of his achievements. He has many certifications in his back. He works on tools like SQL, SAP, Agile, DevOps, and many more. Uh, Shubham. Hello, Shubham.
Yes, hello everyone.
Yes.
Good evening. Thank you,
Yeah.
ma'am, for introducing.
Yes. I would also welcome my fellow colleagues who are in the session. And I welcome all the first year students who are keen in listening to the talk. And now I request Shubham to take over the session.
Sure. So, first of all, thank you for giving me this opportunity. I'll just enable the video as well. Okay. Is the video available for me now? Yeah, I think yes. Okay. So, thank you everyone for joining in. Special thanks to the DSI management who has organized this talk. This itself is an initiative that is taken across to spread the importance of electronics across all branches. If I don't say branches, it's across all parts of our lives. You can put it that way. So with that note, so are we all geared up to explore how electronics is going to be one of the decision-making tools whenever you deliver any solution across any industry? Okay, so we would have people from aeronautics. We'll have people, students from engineering backgrounds such as chemical engineering, civil engineering, even though if people are from architecture, even applies to them as well, right? So I think we are all into this tech era right now, and right from ordering your grocery to firing a space rocket, right? It is all digital at the moment. And given the fact that digital data is, as you are in first year, you might have the notion that digital data is related to computer science only, right? So yes, it is. Your notion about it is right. So, but how does a digital input show you a physical output, right? So let's take a very simple example. Okay, let's take a very simple example of switching on a fan at your place. Okay, so when you switch on the fan, you switch on that, you go to the switch and you click it as on, and the fan starts to run. This is a manual input processor, and it gives you the output as fan being rotated. This is a very layman term of how a common man understands electronics, right? Now, how is it different for us as engineers who have the insights to the technical part of it. Right. I see some very beautiful messages floating on the chat. I think if that needs to be answered.
And no, Shubham, no. You can please continue.
Okay.
Yeah.
Fine. So, okay. So this is up for interaction. So anybody who wants to have some questions can always put it in the chat. So first of all, so we were there in the common man's view of electronics, right? Now, how does it impact and how is it important for an engineer to think about electronics? For example, you are working on any project today, any project, right from designing a building to designing a machine to designing a application over software, or to design something very basic like a toy, all requires electronics. Why? The simple answer is there is a term in electronics called as actuators. Have you heard of this term called actuators? Anybody? Does someone have an answer for that? If you can put it in the chat. What's an actuator? No answers?
Chat is enabled now. You all can type your messages.
Right? Yeah. So let's pause for 10 seconds. So do we have any knowledge of what is an actuator? Fine. Okay. Have you all heard of the DC motors? Right? We had that motor run toys in our childhood. We used to coil it and it used to run. Have you all seen that? Or all are coming from a digital age wherein they all only play a Candy Crush and all the digital things and not anything physical? No answers? Is it so boring, guys? Yes, no, I don't think anybody is answering. Okay, somebody is listening. Okay, fine. Let me go forward. Okay, so the idea is that even if you are from a civil background, you have taken civil engineering as your core and you want to go and design a building. So in today's world, you cannot just land onto the plot and start planting pillars and design a building. You need to have a software that you can visualize. If you are having a good laboratory, we can have a 3D printing of the model, right? So everything is a model first, and then you go to the actuals, because you do not have a chance to correct in actuals, whereas you can do it in a virtual world, right? So electronics provides you these tools. So anything that you see on a system, anything that you see on a digital platform is backed by an electronic circuit or an electronic infrastructure, which is facilitating the digital inputs and processing them and giving you the digital output. So in my college days, where we were doing a lot of small mini projects with robotics and all those fourth year projects that you will be doing in your fourth year, right? Probably before that, you will be able to understand that how electronics will be needed, not only to achieve your solution, but to select your solution. That is the most important factor. So in industry terms, we tell any solution has to be scalable, it has to be feasible, and it has to be practical, right? So your feasibility, scalability, and practicability depends upon what kind of components are you going to use? What is the space are they going to take? Can you put a big generator? So in your cell phones, can you put a big TV tower or the mobile tower? No, right? You need a SIM for that. The SIM is not actually something that is a computer science genius's brain. It's an electronic chip, right? So it's an electronic hardware that will drive you. Now, we are moving fast towards a digital world, and probably we have already taken a big leap towards that. So coming up is the 5G technology, which will again be another step towards moving there. So how do you understand 5G? Is it going to be only the networking that is going to take place, or do you need the infrastructure to drive that 5G? You need the transponders, you need the receivers, you need the stations to manage the bandwidth, right? So even if you are in that field, wherein you are doing a networking thing, or you are planning to build a tower, so you need to know the placement of the tower. You need to know which angle you get the best frequency. You need to know which location you'll get less noise in your networks, right? So this information is, you don't need to be a scholar in electronics, right? You are scholars in your own field. Somebody is a civil engineer, somebody is a mechanical, mechatronics, a medical electronics, even computer science. But do you need electronics everywhere? Can a doctor just do an X-ray with his eyes? Is that possible? Doesn't he know how to run the X-ray machine, or there will be a person who will be assisting on that X-ray machine, right? So if you are working on a Xerox enterprise, so today print media world is also very huge, right? If you are working with a media house and you want to print, so which kind of printer, which kind of technology is you are going to use? It also, see, these are small things which electronics would tell you, which no other, probably no other knowledge box would tell you that. Because electronics is everywhere. We say, I belong to a military background, right? So we have this saying in Indian Air Force, right? So we have this competition between Army, Air Force, and Navy. Okay. So we used to tell our Navy and Army friends that, see, Army is limited to the land, Navy is limited to the waters, but can you limit the air? So that's how electronics is. It's not limited to mechanical or civil or everywhere. It is everywhere. So if you want to excel in the fields that you are in, you would need a bit of electronics knowledge. You would need a professional or a team who's handling your electronics. You would need a know-how of at least how the picture or how the flow between these electronic devices or infrastructure work, right? And the basic electronics would be part of your first year and second year syllabus. So with that, like, I know you'll all be like, electronics might come to you as a very difficult subject. Many people feel that way in the first year. But you would understand the importance of that when you go to your fourth year and you try to design your own bots for mechanical people, when you try to design your own buildings. So when you try to design your whatever, your chips for computer science. So all those knowledge, right, will be required then. And then you would probably have an understanding of why electronics is important, to at least have a basic idea, not an expertise, on the electrical circuits, how they work, right? So in computer science world, they always say it's 0 and 1s, right? There is a saying, computer only understands 0 and 1s. There is no gray area. Similarly, electronics have also understand 0 and 1s, because the 0 is a low voltage and a 1 is a high voltage. That is how your electric circuit works, right? So anything that is a digital in the front end, in the back end, would be supported by an electrical or electronic circuit or an infrastructure. Every server management company, you would be going into big companies in your placements and in your upcoming internships, right? So I did my internship at HAL. So I was part of the Tejas engine and fly-by-wire system. So my fourth year seminar project was fly-by-wire system. So have you ever heard of fly-by-wire? Is someone aware of fly-by-wire? No? Yes?
You all can chat. The chat is enabled.
All right. This looks to be a very calm and quiet batch, I guess. Okay. No, okay, no problem. So you are okay, fine. Let me change the topic. Okay. So you know Kicha Sudeep, right? He was an alumni of DSI. Are you all aware of that? Yes, no? Yes. So he's into media industry. Have you ever been to a film city? Maybe Ramoji Film City or Bangalore Film City. Yes. Do you see electronic equipments there? Right from the camera to the shutter to the video editing to the sound processors, the noise cancellation devices, the power generators. Yeah, power steering for aircrafts. Yes, you can tell it as a cruise control for aircrafts. Okay. Yeah, fly by wire is that exactly. So in the media industry also, right? If you are going to a media industry, you don't need to always be an actor. You can be a voice analyst, you can be a video analyst, you can be a electronics equipment analyst, you can be a photographer. All requires handling of sophisticated electronic equipments, right? So even in those fields wherein art is more involved, today electronics has gone into that. So do you think all these singers today, do they use huge electronic devices at their studios to mix up voices, to do auto tuning, and a lot of things that an electronic device can do? You will learn that in your digital signal processing when you see the digital signals, right? How they mix, what is noise, how it impacts impacts your voice modulations. So these are things which will tell you how electronics is important. If somebody is into cooking, right? Today we have a lot of cooking equipments which are very sophisticated electronic equipments. Have you seen the dishwashers that are being coming these days? And they are in market, they are in the boom. Okay, so they are also a sophisticated electronic equipment. You don't need to learn how to develop that, but do you need to learn how to run that? And if there is a minor issue, do you understand what can be done in an emergency situation? So to understand those small bits and pieces of any industry, because electronic equipments are all around us. If you look around your own house or your place, wherever you are in, you would at least find 10 or more than 10 devices working at the moment, right from your cell phone, your watches, your fans, your lights, everything. These are very common use things, right? Now, let's take a hypothetical dream, right? So many people dream of joining ISRO. Okay, so let's think that we are now scientists in ISRO. Mechanical people are handling the modeling. Civil engineers are handling the launch pad infrastructure systems. Computer science engineers are handling the signal systems which are operating on the various computer screens which you are seeing. Okay. Now, an electronics engineer is part of everything, because everything, the things that I mentioned, is actually an electronic equipment. So if you do not have a basic know-how of a simple electronics basics, which are the core of any design across any electronic equipment, you would not be able to find how to take decisions in a crunch scenario, how to work in a team environment, because the electronics equipment are everywhere. If there is a problem, everybody is talking electronics. Suddenly, everybody is an electronics engineer. They're putting in their thoughts, and there is an expert to evaluate those thoughts. But to generate those thoughts, we need to have a basic know-how of what can go wrong. And like you, I have this industry experience. I can tell you with my experience that major problems during a solution delivery lies in small nitty-gritties, which might be a very commonsensical configuration which was missed, right? So in those all cases, your basic knowledge of electronics would help you. So, okay, a lot of talking from my end. Like if you have some experience till now, so you would have all come from the science background from your PUC or the 12th class and CBSE. And now you would have come to the engineering, you would have thought something that I would want to pursue my engineering in probably a chemical engineering, right? So have you heard of Amul? People have heard of Amul? Amul milk that you get? Yes, no? I see a thumbs up. Okay, yes. Okay, so there is a concept of pasteurization. Do you know about that? What is pasteurization of milk? Yeah. Okay. And how is it achieved? Okay, in Karnataka, we have Nandini milk, right? So if you have a chance at your place to visit to a milk factory, just visit there and see how the milk processing happens and how many electronic equipments are involved in that. This is what I'm talking about. Food processing now, right? So food processing is a big industry nowadays, right? From soft drinks to your other canned foods or your processed meat, everything has an electronics device involved, right? Now, in your upcoming interviews, when you would be applying for jobs, you would be applying for example, you want to start your, yeah, okay. So Deep has a doubt. Okay. Yeah, fire. I see someone has a doubt. So you can share your doubt or you can unmute if you have that option, or you can put it in chat. Anything is fine.
We can take the question answer session at the end.
Sure.
If you want anything, you can just put a message in the chat group. Chat.
Right. Okay. Okay. So I note I have a big doubt. Okay, let's address it then. Okay, put it in the chat. Let's address it then. Let's clear the big doubt. Probably I'll clear some.
I request all the students to please maintain the decor of the meeting. Yes, Shubham, you can please continue.
Okay. Okay. So what I'm saying is, whenever you now go for an interview, right, and you go and try to apply, for example, you're applying to Ola, which is into electronics EV vehicle industry. That is one of the biggest industries which electronics is looking at right now, right? So you will have mechanical engineers who will drive and who will make the design of the system. You will definitely need a lot of electronics knowledge into that. Now, why do I say that? So whenever you design an equipment, right, you need to structure your equipment such that your payload is adjusted according to the design and it does not disturb the aerodynamics of the system. Your payload is out of heat. It doesn't generate a lot of heat. It has good exhaust system. Your payload is safe and it doesn't get damaged during the ride or in a small accident, or in case of wear and tear should be less. All this is what we are talking about. And this is a designing issue, right? A mechanical engineer is deployed to design the Ola bike and he's thinking about where should I put the odometer, where should I put the engine, where should I put the battery, where should I put the wheels, where should I put the brakes, where should I put all the electronic devices. Now, everything that you are thinking of is an electronic device, right? So a decision is being made at the mechanical division of Ola, thinking about the payload they have to put. The payload is an electronic device. So if you don't know how an electronic device reacts to these kind of scenarios, you will not be able to take a decision of where to put it. So you will definitely have a team of experts who are into electronics. That is no doubt. But is it not good that if you have some of the expertise at your own self, the basic knowledge, so that in case there is a counter question, you can always challenge an idea. Why this? Why not this? Why solution A and why not solution B? Right? So this is something that you can take an example of. Right. And there will be a lot of examples across all industries. Any employer today, right, wants you to have multiple skills and one major skill. Right. So one of the multiple skills, if you are going to an industry of manufacturing, would be electronics. Definitely would be electronics. Right. If you're going into software industry, for example, there are a lot of computer science students. They'll be thinking, for me, how electronics, right? So for example, you are into your computer industry, okay? Now you are into, for example, you are in Apple, okay? And you are devising Apple's camera, you are making a software so that it can filter the details, it can filter the extra noise, it can do n number of things. That is your assignment. Well, now where does electronics come here? The part is your camera, the capture device is an electronic device. If you do not understand how the image capture is happening, what are the details of the image that can be used to improve the quality, your software cannot process the inputs if you do not know what inputs the camera is getting and what output the camera is giving to you. So camera's input is the visual side. Camera's output is the picture. Now that picture is actually the input for your system, the software. Now you need to process that picture to fine tune it or to add filters, right? And then you need to work with the pixels, which is image processing, which is again part of electronics. So I don't believe there is any field, right, which doesn't need the basic know-how of electronics. Okay, so let me give you a layman example nowadays. Nowadays, a lot of people are into public speaking and a lot of people are making YouTube videos or Instagram reels. If you do not understand how to use the mic, which angle to use the mic at, and if you do not understand how the microphone would behave in a closed room versus a big open hall, so you would not be able to understand the dynamics of making your Instagram reel, or if you're YouTube, how do you manage that, right? Because all those are being done by an electronics device. So you need to know the behavior of your electronics device the best way. And this will only come whenever, so there was an old, I don't know, what do I say that? Old trick, right? If your phone gets wet inside a bucket or a rain or somewhere else, just put it in the bag of rice and it would get working again. So that again is a part of your basic electronics. If I switch on something wherein everything is connected, every port is connected to every other port, that means my water is acting as a conductor between two ports, which might be of the same value or opposite value. It can corrupt my circuit. So this is a very basic example of understanding how does a short circuit happen, right? So yes, okay. I think then now we are in time to address your big doubt. So I think we are up for questions, and probably I did a good job to cover most of. I thought yesterday, what do I say? Because it's everywhere, right? So you do not find a place where you do not have electronics, right? Even from cutting a tree, which requires a saw, you need to put it at an angle. You need to manage the speed. From grinding your chutney, which is a grinder, again an electronics device, right? So you might be thinking that I don't learn about a grinder in a BTech or a PE course. I don't learn about a chutney making grinder, right? I don't do that. But if you open the chutney making grinder, you will find a circuit. Can you read that circuit? Can you understand that circuit? A basic circuit, right? That is how your basics of electronics works across the branches, across all fields, not only engineering, but even in the medical field, you cannot avoid electronics. That is the reach and that is the importance of this branch, as well as the outputs that it produces across all the other fields of life, right? From farming, cooking, military aviation, even if you're recoil of a gun, everything has an electronic angle to it. And every known reason, electronic evidence nowadays is one of the best evidence in any criminal case or a terrorist attack where you're doing an investigation, right? So your know-how of an electronic device gives you an edge over your peers in any industry that you are in, right? Okay, so a lot of one-way talk. I would like to listen to you or see your comments.
Yes, first I would like to thank Shubham as he has covered all the branches of engineering in which he has thrown light on how electronics is a very significant branch or a study topic which would help all students irrespective of technical, even non-technically. We all know applications where electronics is involved. So first I would like to thank Shubham wholeheartedly for his talk. Later I would thank our HOD, Dr. T.C. Manjunath sir, who has given us an opportunity to conduct this AAT, like alternative assessment. Then I would thank all my fellow teachers who are handling basic electronics with me, Dr. Pavitra ma'am, Aishwarya ma'am, Sindhu ma'am, Shruti ma'am. I would like to thank all of you for the kind cooperation in conducting the AAT. And I also thank all the students for their patience listening. Now I would be giving the access to unmute for all the students, but I request all the students to take only technical electronics related questions to the speaker and maintain your own dignity. Thank you all. Yes, now you all can unmute yourself for the questions. Yes, Gagan from G section, you have a doubt? Yes, do we have Sudeep in the meeting who had a big doubt sometime before?
Maybe everybody are after starting this.
What man? Tell me. Everybody are.
Give chat access, ma'am.
Yes. Are there any doubts? I'm asking you all again. Otherwise, we can wind up the meeting. Any doubts from the students? Yes, Bhuvan Kumar, you have a doubt? Okay, then, yes, Shubham, can we have your video turned on?
Yes,
Yeah,
ma'am.
thank you so much,
Thanks a
Shubham.
lot, ma'am.
Thank you so much for the talk. And I'm very proud to tell that Shubham is also my student at the DSATM. And he is a very dynamic person as I've seen him since 2012. So I would like to thank you for our invitation, accepting our invitation. I know you're taking this call from the office. Thank you so much, Shubham.
Thank you,
Thanks
ma'am.
for your
Thanks for the
time.
opportunity.
Thank you.
Yeah, thank you, everyone.
Thank you. Thank you, dear students. I will end the meeting.